number systems. If you take number system, there are number systems. The familiar number system is decimal number system. That is we are familiar with that number system. There is the ordinary number system. We learn from the from our childhood, no? Base 10 numbers, right? Base 10 numbers. Now when, especially in computer applications, you use binary numbers and hexadecimal numbers, right? Binary numbers are the numbers of base 2. Hexadecimal numbers are the numbers of base 16. So we can discuss other numbers of other bases also. So if you take any number, let's say last time we discussed numbers of base 4, no? Base 4 numbers. For example, base 4 number can be base 4 numbers, you use numbers symbols 0, 1, 2, 3, no?
Yes, sir.
These 4 symbols. 0. The value of 0 is 0, value of this 1, value of 2 is 2, value of 3 is 3, right? Like that. But for our familiar numbers, that means decimal numbers, so numbers of the base 10, so you use the symbols from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 symbols, right? From these symbols, you can express all the numbers in ordinary numbers, right? Using these 10 symbols. When you consider from 0 to 9, there are 10 symbols, right?
Yes, sir.
From those symbols, you can write down the numbers, all the numbers. So 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How do you write 10? Do you use another symbol for that?
Yes, sir. A.
No. You just you form that number using same set of symbols. So 1, 0. We are discussing our family numbers, not the hexadecimal numbers, right?
Yes, sir.
Then 11, 12, 30, 40, 50, 60, 70, 80, 19, 20. Like that, you can write many as much as possible. As much as you want, you can write down the numbers like this. Then imagine when you write numbers of base 4. When you write numbers of base 4, right? How many symbols required? 4 symbols. You need only 4 symbols. 0, 1, 2, 3. Imagine you are not known as other than these 4 symbols. Okay?
Yes.
Then how do you write the numbers? How do you write 1, 0? 0 you can use plus symbol. For 1, you can use this symbol. For 2, you can use this symbol. For 3, you can use this symbol. 4, do you use a new symbol?
So 4 we have to 0, 1.
1 0. Right?
Sir, how can we know that it is 1, 0?
Because only you can use only these four symbols. When you write 4, you have to 1 0. Then 5, 11. 6, like this. 7,
30.
1 3.
Yes, sir.
14, 7, so 8, 1 4. 9.
Sir, why 1, 4, sir?
Sorry. 1 4. Yeah, you can't take 1 4. Yeah. Because only you can use symbols.
2, 0?
Yes, that's right. 2 0. Good.
Yes, sir.
2 0. Then 2 1. 2 2. 2 3. 3 0. 3 1. 3 2. 3 3. 4 0. 4 1. Like that, no? So this is 14. 4, sorry, not 14. 7, this is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? Like that.
Yes, sir.
So you can write down any amount of numbers. Right? Then we discuss decimal numbers. How to expand decimal numbers? Any number systems, there's a method of representing these numbers, right? For example, decimal numbers. Let's say this number, 4276. How do you write these? These are ones, right? These are tens. These are hundred. These are thousands. Right? So if you expand this number, you can expand like this: 4,000 plus 200 plus 70 plus 6. Right? So you can write like that: 4 into 10 to the power of 3. 400 is 4 into 10 to the power of 3. 200 is 2 into 10 to the power of 2. 7 into 10 to the power of 1. What is 6? 6 into 10 to the power of 0. 10 to the power of 0 is 1. 10 to the power of 0. 0th power of any number is 1.
Yes, sir.
So, like this, you can expand like that, right? Any number. For example, then how do you expand this number? Let's say 6, 0, 2, 1, 5, this number. How do you expand it? 6
This
into
2, 10,
10 to the power of 4
4.
plus 0 into 10 to the power of 3 plus 2 into 10 to the power of 2 plus 1 into 10 to the power of 1 plus 5 into 10 to the power of 0. So you can expand this number like that. Okay?
Yes, sir.
Right. Then how do you expand this? Now this are our family system, decimals. decimal number system. So this is ordinary number system. This is ordinary number system. Numbers, how you know how to expand those numbers. Then how do you expand numbers of base 4? Uh, 2, 1, 3, 2. If you take this number 4, 3, 1, 2, this is, what can you say about this number? Is this base 4 number or not? Is it base 4 number? Is it no, because
base 3.
4 cannot include in base 4 numbers. 4 is not there, no? 4, the 4 shouldn't be there. Okay, 4 shouldn't be there. So this is not base 4 numbers. This is not base 4 number, right? But these 4 numbers, because you know only 0, 1, 2 and 3 can be included in that base 4 number, right? So this equal 2 into 4 to the power of 3 plus 1 into 4 square plus 3 into 4 to the power of 1 plus 2 into 4 to the power of 0. That is how you expand base 4 number. Base 4 number you expand, but this is now if you expand like this, base 4 number can be expanded. But 4 cannot include left hand side, but 4 is there in right hand side. Okay, 4 cannot include in the number. But for the base 4 number, always power forms from powers of 4, right? Powers of 4. So if you simplify this one, you can, if you simplify right hand side, you can have the value of this number in ordinary value. Let's call ordinary value. Ordinary value. That is decimal value. Value in the decimal system, so you can call it ordinary value. So what is the ordinary value of this ordinary value or actual value? So you can say actual value or ordinary value or in the decimal value. So how did it, what is the 4 to the power of 3? 64, no? This 4 squared is 16. This is 12. 4 to the power of 0 is 1. So this is 2. So 128 plus 16 plus 12 plus 2. Right? So this equals 30 plus 158. Okay? 148 to 150, 150, no? Right. No. This is 48, no? 148. Okay. 140. So this is this decimal value. Decimal value you can put like that. So this is the base 10, right? So 2132 is the base 4 number. This base 4 number in decimal value or ordinary value is 148. So like that you can evaluate, right? Then how do you write any number any other ways also in similar way?
So can you tell why are we writing like below it 10?
What did you say?
Below 48 you wrote 10. 10 means?
10 means this under base 10.
Okay.
Base 10. Base 10 means our ordinary, this representation the ordinary number as an ordinary number. Right? Ordinary number means your family number, you are familiar with from your childhood. Right? Family number. There is 148 to the base 10. But left hand side there is a number in base 4. Right? Base 4 number. Likewise, what is if you write down any number of base 3. How do you write down number of base 3 then? How many symbols required to write base 3 numbers? 0, 1, 2 only. Right? These are the symbols, required symbols. Right? When you write base 3 numbers, you need 3 symbols. 0, 1, 2. Okay. Then how do you write numbers? What is the way of writing these numbers? 0, 1, 2, 3. How do you write 3? 1, 0. 1, 1, 1. This is 4, this is 5. No, 5. This is 1, 2. Then 2, 0. 2, 1. 2, 2. 3, 0. 3, 1. 3, 2. 4, 0. 4, 1. 4, 2 like that, no? So this is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. Like that, no?
Yes, sir.
So we can write only you use 3 symbols only for base 3 numbers, right? So you can expand in the similar pattern. Let's say 2, 1, 0, 2, 3. No, 3 not there, no? Boom. This is wrong, eh? 2, 1. This is 20. Here, this is 6, 7. This is 8. But 9 is this 9, 1, 102, 103, like that. See, this is not there. That's not there. Earlier also we did some small mistake. Let's see that also. Right? So here it is then 1, 101, 102, 110, 111, 112, like that, right? Numbers are going like that. Only usable 1, 0, 1 and 2 only, right? Only these three digits you can use, right?
But so 0, 1, 2 only.
0, 1, 2 only, that's right. When you write base 3 numbers, always 0, 1, 2, right? But earlier also I have done a small mistake. Let's see there. You will see that somewhere here. This one, no? This one wrong. Here, not 40, eh? 40. This is the last number. Then next number is 100. 101, 102, like that. This goes in that line, right? Only this when you take base 4 numbers. When you take base 4 numbers, only 0, 1, 2, and 3 only, right? Included. No other digits, you cannot, not usable other digits, right? Okay. Uh,
Sir, like I'm confused. 0, 1, 2, 3, then?
Next number.
Yes, sir, next number. But the other one you did 0, 1, 2,
0, 1, 3, right?
3.
Then
But for the below one, it will be till 1, 2, like 11, 12, and then again 20, 20 to 21, and 22, sir, like that.
22, but it's not the 22, eh? It is this actually this 7, this 8, this 9, 10, like that. This goes like that. Then next number is 100, 110, 111, 113, like that. 120, 121, 123. Right? 130, 131, 133, 1, 100, 330, 200, like that. Okay, 200. So you can write down any amount of numbers in that system. So if you can identify the pattern, then it is easy, right? Uh, right. Then let's see how you can expand these numbers. How do you expand base 3 numbers? So this equals 2 into 3 to the power of 5 plus 1 into 3 to the power of 4 plus 0 into 3 to the power of 3 plus 2 into 3 to the power of 1 plus 3 into 3 to the power of 0. Is it clear? Right?
Yes, sir.
So this is base 3 number, right? So what is the right hand side value? Actually, base 10 value. Base 10 value means ordinary value. Value in the ordinary number system or actual value, right? So 2 into what is 3 to the power of 5? Hmm? Uh, 243, no? This is 81 plus 0 plus 6 plus 3. 90. Here plus 6, 8, 4 plus 90 equal 0, 5, 9, 506, 9 plus 6, 9 plus 8, 17, 576, right? Okay,
Yes, sir.
576. So this is base 10. Base 10 value. Likewise, how do you develop binary system, binary number system? What is how do you write in binary? In the binary number systems are the numbers of the base 2, binary numbers. Right? So you can use 0 and 1 only. Only 2 digits you can use, not more than 2 digits. Right? Only includes numbers like that. These are binary numbers: 0, 1, 0, 1, 1, 0, 1, 1. Only 0 and 1. Right? These are binary numbers. Binary numbers. Uh, Binary number system, how do you write the binary number system? 1. First number is 1. So you can write 1. Then how do you write 2? 1, 0. How do you write 3? 1, 1. Then 2, 0. So then what is it? How do you write number 4? 1, 0, 0. I will tell you very easy method, right? Don't worry about that. I am just telling how to this pattern. If you can understand this pattern also, that is also important. But without that, also, without using that, you can manage. Don't worry about that. This pattern, right? 1, 0, 1, right? 1, 1, 0, 1, 1, 1, then 1 0 0, like that, no? Hmm? Like that. So 1 0 0 1, 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0.
Like, can you explain how I will be converting them? Like, these are the values of 1, 2, 3, 4, 5, right? These are the thing teacher was doing, but I was confused. Like how, like he was like find the value, find the final value of
But I think
eight.
teacher is not given this pattern, writing pattern.
Yeah,
Actually,
he got.
without knowing that, you can manage. I will tell you now. Don't worry about
He
that.
was.
But
So he was like,
but without this, how do you manage that? I will tell you easy method also, right? Don't worry
okay.
about that. You try to practice this this pattern also, right? One,
He was saying,
yeah, 1 1 0 0 1 1 0 1 1 0 1 0, right? Then 1 1 1 0 1. No, 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 no. It's 1 0 0 1 0 1 1 1 0 1 1 0 1 1 1 1 0 1 1 1 1. Right. Okay. Right. Like that. So you can like fill that. So these are actually, this is 1, this is 2, so this is 0, this is 3, this is 4, 5, this is 6, 7, 8, 9, 10, 12, 10, 11, right? 11, 12, like that, eh? Like that. But actually, you can practice like that. For example, suppose you want to, now similar way you can expand these numbers. For example, let's see, now onwards you try to understand. I can tell you two methods of converting uh, numbers into binary. Hmm? Easy, two methods. I'm going to tell you two methods of converting numbers into binary numbers, right? Hmm. first thing you should understand how you expand these numbers. For example, let's say this number 1 0 1 0 1 1 1. How do you expand this number in decimal system? So here you have 2 to the power of zeros. This one 2 to the power of 1. This one 2 to the power of 2. This one 2 to the power of 3. This one 2 to the power of 4. This one 2 to the power of 5. This one 2 to the power of 6. Okay? Then how to expand this number? So you can write 1 into 2 to the power of 6. Okay? 0 into 2 to the power of 5 plus 1 into 2 to the power of 4. Okay? Plus 0 into 2 to the power of 3 plus 1 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. That is how you expand these numbers. Right? But each number multiplied by either 1 or 0. This one 1 into what is 2? This is 16. Right? This 0 into, sorry, 32, no? 32. This 32. No. What is 2 to the power of 6? 64, no? Okay. So 2 to the power of 6 means what do you mean by 2 to the power of 6? 2 into 2 into 2 into 2 into 2 into 2, 6 times, okay? Right? 2 to the power of 6 is 6 times. If you multiply, you get 64. Right? Then this one, 0 into 32 plus 1 into 16 plus 0 into 8 plus 1 into 4 plus 1 into 2 plus 1 into 1, like that. Is it clear?
Okay.
So finally you will get 164. 0 into 32, 1 into 16, 0 into 8, 1 into 4, 1 into 2. Then when you calculate this number, for example, very simple way, C 1 0 1 0 1 1 1. So when you calculate this number, so you can just write 64. 64 plus, this is 64, next one 30, not 32 term, this is 0, then plus 60 plus 4 plus 2 plus 1, like that. Okay? Right? So this equals 80 plus 25 equals 105. So this is in decimal form, this is in under base 2. Okay? Is it clear? Is it clear? Hello?
So this is 105.
Yeah, 105 usual number. Ordinary,
Yes, sir.
in the ordinary
So
number.
this one, yes, sir. This one I understand. So, like how can I say? If he is giving, for example, give me the binary answer of like 64 plus 32. Like he says, give me the binary one.
Right, so very simple way you can expand.
So, like teacher, he is giving, he's saying like 12 with 7 and give me the
Yes,
binary.
yeah, I know that. Don't worry about it. First things you understand, then you can by yourself
Yes,
you can
sir.
manage. Don't
This
worry.
one I understand, sir.
Right. Then I will tell you very easy method because I asked you to write down that pattern, right? Uh, but without writing that pattern, let's say you want to convert one into binary. Yeah, so there we have two methods, right? Two methods. Convert binary. Okay. First method is for small numbers. Let's say, suppose you want to convert one. One is actually one, eh? Two. Two means 2 to the power of 1. Okay? 2 means 2 to the power of 1.
Yes, sir.
So 2 to the power of 1 is, so 2 to the power of, so you can write 1 into, so 2, this is 1 into 2 to the power of 1 plus 0 into 2 to the power of 0. Okay? Right? So this equals 1, 0. Okay? 3. 3 you can separate into 2 plus 1. Right? 2 plus 1. This is 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. What is that? So it is 1, 1. Okay. 4. 4 can be written as 2 squared plus 2 squared plus 0 plus 0. Eh? That is 1 into 2 squared plus 0 into 2 to the power of 1 plus 0 into 2 to the power of 0. So what is this? 1, 0, 0. Is it clear? Is it clear?
2 to the power 2 plus 0, 0.
Yeah. 5 is, so you can write this one 4 plus 1. 4 plus 1. So this equals 1 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. So this equals 1, 0, 1. Okay? Like that. 6. Like that. Let's say, suppose you want to write 17. How did I write 17? 17 you can write like that. So 16 plus 1. This is 2 to the power of 4 plus 1, right? So this equals 2 to the power of 4. So 1 into 2 to the power of 4 plus 0 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. So what is this number? 1, 0, 0, 0, 1.
Sir, how, sir? Can you show me again?
So you just pick up this number, isn't it? 1, here 1, is 0, is 0, is 0, is 1. Okay? Right?
Sir, wait. From where we are getting, sir, 0 into 2 raised to 3, sir?
But 0, that is 0. No? So you should have 2 to the power of 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. But these values are missing in this number. So you put zeros. Only available these two now.
No, sir. I'm saying 1 raised to 2 raised to 4, sir, from where we'll get.
1 is to 2 to the 4. This
Yeah.
one. Yeah, it is 2 to the 4 equals 1 into 2 to the 4. Same thing.
Okay. So that gives me 16.
Yeah. So 1 is equal to 1 into 2 to the power of 0. 2 to the power of 0 is 1. This is 1. 1
Yes,
into
sir,
1 equals 1.
like how we are going to know we have 0 into 2 raised to 3, like 3.
Yeah,
3 0.
this one equals 0 into 2 to the 3 is what?
No, sir. I'm saying why are we having 4 times? How will I know, sir?
4 times.
Oh, okay.
Yes, it's,
Yeah.
you just multiply. You should be familiar with this.
No, sir. I know that. Now I understood, sir. So these all, it will be zeros because that is, we only put 16 and 1.
Yeah,
So we
16
take
and 1. Yeah. This and this.
Yeah, 2 raised to 0 gives me 1. Yeah, now I understood, sir.
Right. Okay. What is the other method? Actually, this one also. You just tell me any other number. Hello?
Yes, sir.
You just tell me any other number.
32.
32 is very simple. 32 is actually 2 to the power of 5, no? Right? 2 to the power of 5. So 2 to the power of 5 means 1 into 2 to the power of 5. Then 0 into 2 to the 4. 0 into 2 to the 3. Plus 0 into 2 to the 2. 0 into 2 to the 1. 0 into 2 to the 0. So this equals 1, 0, 0, 0, 0, 0. This is the power of 5. Tell me any other numbers. 45?
Yes, sir.
45 can be separated as 32 to subtract 32, 13 is remaining, then 8, 40, then 4 plus 1. Okay. 45 is 32 plus 8 plus 4 plus 1. Is it clear?
Yes,
32 plus 8 is 40, 40 plus 44, 44 plus 1 is 45. Now you can write down this is 2 to the power of 5. 1 into, so this equals 1 into 2 to the power of 5 plus 0 into 2 to the power of 4. 2 to the power of 4 means 16, huh? No 16, 16 terms. Then 1 into 2 to the power of 3 plus 1 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. Okay.
yes,
So this equals 1, 0, 1, 1, 0, 1. So this is 45. Okay.
yes,
So other method of converting into binary is this method. 45. So 45 you just write 45 like that. 45. Divide by 2. So this equals 22. Remainder is 1. You divide 45 by 2. It's 22. Remainder is 1. Then again divide by 2. Remainder is 0. Again divide by 2. Quotient is 5. Remainder is 1. Again divide by 2. This quotient is 2. Remainder is 1. Again divide by 2. So this is 1. Remainder is 0. Okay. Now you count this side. In this direction, you take this thing of numbers, that is equals 1, 0, 1, 1, 0, 1. Is it clear? Same thing, no? You see? This and this are the same thing. Is it clear?
yes, yes,
That is the other method of converting this number into binary number. Very simple. Very simple. So, how do you convert 45.16 into binary? First you convert 45. 45 to convert 45, 1, 0, 1, 1, 0, 1. Then how do you convert 0.16 into binary? This is fractional part, decimal part. Decimal part of the decimal number, right? So if you convert this, you just multiply by 2, right? You just multiply by 2. If you multiply by 2, what do you get here? 2, 5. 0.32. No perfect numbers are remaining. Okay. So unless if you get any number in the before the decimal point, So you took it here, right? Then you multiply again by 2, right? Then if you multiply again by 2, 0.64. No. If you multiply by 2 again, this equals 1.28. Right? If you multiply this one again, you get 1.28. So you take only 28 this here, 0.28. That this one you take here, like this. Okay? Then you multiply this one by 2. Then this equals 0.56. Right? No perfect number. Get like that. Okay. Then you multiply this one again. Right? Then 1.12, no? You put only 0.12. This one you take here. 1. Is it clear?
Yes, sir.
Right? Then you multiply again like this. 0.24, this 0. Then you multiply again 0.48, 0 like that. Now, this is not terminating, right? Terminating, so you can calculate number, several number of places and complete. But you count in this, now you count in this direction. You keep in mind, very important, this is very important. So you count in downwards direction, right? Right? Downwards. Here upwards, right? You see?
Yes, sir.
So you take this thing upward, but this thing you take downwards. Then this equals, here put dot, final value equal 0, 0, 1, 0, 1, 0, 0, like that. So you can find many decimals more, right? So you can put dotted line like that. Okay.
Yes, sir.
Right. Then how do you convert hexadecimal numbers? Hexadecimal numbers. So last time we discussed somewhat hexadecimal numbers also, no? Right. Hexadecimal numbers. Oh, numbers. Numbers of base 10, base 16, base 16. So base 16 numbers are, then how many symbols required for base 16 numbers? How many symbols? But base 10 numbers you need 10 symbols. Base 4 numbers you need 4 symbols. Base 2 numbers you need 2 symbols. Likewise, base 16 numbers you need 16 symbols. How do you take the 16 symbols? Hello?
Yes, sir.
So you can take 0, you can take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have only 10 symbols. You need another 6 symbols. No? Put another symbol. So you use capital letters. First 6 letters of English alphabet. Here you have, here you have 10 symbols. You need another 6 symbols. So A, this is 10, 11, 12, 13, 14, 10, 12, 13, 14, 15, 10, 10, 10, 11, 12, 13, 14, 50. Okay?
Yes, sir.
How many symbols are there now? Hello?
Yes, sir.
How many symbols are there here? Number of symbols?
16.
16 symbols. Right?
Yes, sir.
But you count up to 50. Right? There are 16 symbols, but you can count up to 50. So this is 50. This is 50, but here you have 16 symbols. Okay? Is it clear?
Yes, sir.
Here there are 16 symbols, but using these symbols you can write down numbers. For example, you can write down this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How do you write down 16? 16 is 1, 0, 15, 17, 1, 1. 1, 2 is 18. So this is 18. 18. This is 19. Like that. So you can, if you know that pattern, you can write down any number, right? But let's say this number. How do you expand this number? A, B, 7, 1. So this is hexadecimal number. How do you expand it? In binary system. Binary system expansion is A is actually, this position is, this is 16 to the power of 4. Here 16 to the power of, here 16 to the power of 3. Here 2. This one 16 to the power of 1. This one 16 to the power of 3. So how do you expand this one? What is A? This is actually in binary equivalent to 10 here. This one binary equivalent 12. This one binary, sorry. This one decimal equivalent 10. This one decimal equivalent 12. This one decimal equivalent 13. This one decimal equal 14. This one decimal equal 15. sorry, is 11, 12, 13, 14, 15. Eh?
Yes, sir.
Decimal equivalent like that. So how do you expand it? A means 10. So 10 into 16 to the power of 3. B means 11. That is 11 into 16 to 16 square plus 7 into 16 to the power of 1 plus 1 into 16 to the power of 0. Is it clear?
Yes, sir.
So decimal value you can find from this. Very big value, right? So you have to get 16 to the power of 30. Right? 16 to the power of 30, so it is very big number. Right? Shall we try easy number? Let's say 1, 2, 1, B, A. Hmm? B, A. How do you convert this one? This 2 into 16 to the power of 3 plus 1 into 16 to the power of 2 plus B is 11. 11 into 16 plus A is 10. 10 into 16 to the power of 0. Right? Again, 16 to the power of cube is required. That is, you need 16 into 16. 256 into 16, 36, 33, carry 1, that is 15 plus 6, 9 is 4096 plus 256 plus 16 into 176 plus 10. So this is the number, so you have to add these four numbers, then you can get the decimal equivalent of that number.
Yes, sir.
8, 8 plus 1, 8 plus 13 plus 21, 3, 5, so these are the values. So this decimal equivalent, this number, this is decimal equivalent, this is 21 BA to the base 60. Base 60 number equal to this. Right? There is show, then how do you convert decimal to binary to hexadecimal and hexadecimal to binary? How do you convert decimal to decimal numbers? decimal numbers to binary and binary to decimal. Decimal. First of all, this number 1 0 0 1 2 0 1 1 2 1. You can convert hexadecimal to sorry, hexadecimal numbers to binary. Hexadecimal. Hexadecimal numbers to binary and binary to hexadecimal. Let's see how you can do that. Binary to hexadecimal. Very easy, eh? Binary to hexadecimal and hexadecimal numbers to binary. Now this is a binary number. It is obvious binary number, no? This is a binary number. Now this binary number you separate into 4 digits like that. 4 digits. You can separate starting from right hand side. Right? So you need each portion should have 4 digits. These four digits. 4 digits. Right? This is also another 4 digits. Other 4 digits how do you complete? 0 0 0. The other 4 digits. Right? But what is this? What is this number? Hexadecimal equivalent. What is this hexadecimal equivalent? This one. Can you tell me what is the decimal equivalent? What is decimal equivalent? This if you take 1 1 1 0.
Yes, sir.
So this is this is equal to 2 plus 4 plus 8, no? Right? So this equals 14. 14. What is 14 in this hexadecimal? You know 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay, A, B, C, D, E, F. Like that. Now what is then 14? So this is 14. 14 is actually The decimal equivalent is 14, that is equal to E. So you can put E here. What is this? This is 2, no? 2. Hexadecimal also equivalent to 2. This is 1. So this is equal to 1, 2, E. That is how, so this hexadecimal equivalent to 1, 2, E. Okay. Hello?
Could you say it again?
You separate into separate into 4 digits. Starting from right hand side. The first 4 digits actually indicates E. Second, next 4 digits indicates 2. Right? Last 4 digits equal to 1. This 1, 0, 0, 1 is 1. So the hexadecimal equivalence also 2 is equal to 2. Okay? 1, 2, E. Now you can check whether this is correct. Now 0, now yeah, we convert 1, 0, 0, 1, 0, 1, 1, 1, 0. What is this is 2 plus this is 4 plus this is 8 plus this 60, this 32 plus this 64, this 100 and 128, so this is equal to 256. So you have to add this number, so this is equal to 14 plus 50, 306. Okay, so this is equal to 306. Now in hexadecimal number, E. So so 1 into what is 14 into 1, 16 to the power of 0. You know how to expand this, no? How do you expand it? So E is 14, 14 into 16 to the power of 0 plus 2 into 16 to the power of 1, right? So 1 into 16 to the power 16 to the power of 2. If you simplify this number, this is 256, this one 32 plus this one 40. So if you add these three numbers, 2, 4 plus 2, 6, 6 plus 6, 2, something went wrong, no? Something went wrong. 4, then 6 plus 6, 2, 1, 2, 5, 0, 302. But here we got 306, no? Shall we check it again? This is 2, these are 4, this is 6, this is 8, this one 16, here 32, no? 32, right? Here 302, right? Okay? 32, 300. Okay? Now hexadecimal, very easy way to convert like that. Then how do you convert hexadecimal numbers into binary? Very simple. So this is hexadecimal number A, T, B. How do you convert this to binary? Hexadecimal to binary. So very simple. What is A? A is 10. A equals 10. A equals 10. 10 equals 8 plus 2. So this equals 1 into 2 to the 3 plus 0 into 2 to the 2 plus 0 into, so 1 into 2 to the 1 plus 0 into 2 to the 0. So what is this number in binary? 1, 0, 1, 0. 10 equals 1, 0, 1, 0. Right? Then 3. What is 3? 3 is equal to 2 plus 1. So this equals uh, 1, 1, 1. 1, 1. Is it clear? Hello? Now you take A, B. So B equals hello?
Yes, sir.
What is B? B is 11. 11 equals 8 plus 2 plus 1. So this equals 1 into 2 to the 3. Right? Then 0 into 2 to the 2 plus 1 into 2 to the 1 plus 1 into 2 to the 0. So this equals 1, 0, 1, 1. Okay. Now this again you can write 0, 0, 1, 1. Because you have to set 4-digit numbers. 4-digit. Now each, what is A? A is 1, 1, 0, 1, 0. What is T? T is 0, 0, 1, 1. Right? What is B? B is 1, 0, 1, 1. So this is the binary equivalent of hexadecimal number. Very simple. Okay.
Yes, sir.
Right? So very simple. Yes. I will give you a few examples. Can you try these numbers to convert these numbers binary? Convert the following numbers. The following binary numbers. By numbers to hexadecimal. 1 1 0 0 1 1 0 1 1 1 0 1 2 1 1 1 0 0 0 1 1 0 0 0 1 1 1 8 1 0 1 0 1 0 1 0 0 1 8 1. Convert the following hexadecimal numbers. Binary. One, two, eight. Three, four, nine. One, two, four, B, eight. Three, one, eight. Those four numbers you have to convert into binary. Hmm? Can you manage this? Hello? If you take first one, this one, so you separate into 4-digit bundles, like this, 4-digit bundles. What is the 4-digit? What is 1001? What is this? 101. If you separate into bundles like this, first one is 1001. Second one is 1011. Next bundle is 11101. Is it clear?
Yes, sir.
What is this one? In hexadecimal. In hexadecimal. First you convert into decimal. Then you can convert into hexadecimal, right? 1, 1. This actually, this 2 to the 0, this 1, this one 1, 1, these are 2, these are 4, these are 8. So this is actually 8 plus 1, no, 9. So 9 is 9, eh? So this is equal to then 9. Then this one equals 8 plus 2 plus 1. That is 11. Right? So what is the decimal equivalent of 11? Sorry, hexadecimal equivalent of 11. What is hexadecimal equivalent? Hello? Here 9 is hexadecimal to the base 10, 9 equals base same thing, no? Base 16 also, same thing, no? And the base 10 and base 16, 9 is same, same symbol. But 11 is, what is 11? 11 is B, no? Equals B. 1101 is what? What is 1101? That is 8 plus 4 plus 1. So this is 30. 30. This is D, no? D. So this equal, then hexadecimal number is, this one equals 9 BD. Okay. So this equals 9 BD. So this equals 9 BD, this under hexadecimal is there. So like, right, in that manner you can convert other numbers also. How do you convert this one into hexadecimal binary number? Now you want to convert this to binary number. So you see, what is 1? 1 is 1. 0, 0, 0, 1. What is 2? 2 is 0, 0, 1, 0. Right? What is A? A is 10. A is 10. A equals 10. So this equals 8 plus 2. That is 1, 0, 1, 0. 1, 0, 1, 0. 1, 0, 1, 0. So this equals 1, 0, 0, 1, 0, 1, 0. So this is this binary equal. Right? Very simple. So finally you can cut this beginning zeros, no value, you can cut that 3 zeros. Then you get this is the binary equivalent of this number. 1, 2A. 1, 2A is equal to this one. Is it clear?
Yes.
Right.
Can you show sir it's once again? The second one.
This one, 1, 2A.
Yes, sir.
1, 2A. So 1, 2A. So what is
What is the value?
what is
How we
one
find for one?
1 2 8? What is 1 in binary? So what is 1 in uh, one the one in one the wine this one 110 no? 110 what is decimal equivalent? Hmm? Also 1. What is the one in what is the one in hexadecimal equivalent? That is also 1. Hmm? 1 is hexadecimal 1. 1 is binary equivalence also 1. Hexadecimal equivalence also 1. Hmm? So one is one you can write 1. So addition because always you consider 4 digits, no, that's why we put if you put 4 digits number, so you have to apply 3 zeros at the beginning. Hmm? Then this is also 1. Hmm? 2 is what is 2? 2 is what is binary equivalent to? 2 is 1 0. Hmm? So at the beginning, additionally you can put another 2 zeros. Then what is A? A is 10. Hmm? 10 how do you convert into binary? So you can follow this method also. We have 2 methods now. Hmm? Like this. This method is easy. 2, 1. 1 0 1 0. 1 0 1 0. So I just put like that.
Can you show with the two second one? So the second
Yes,
one we
sir.
are sketching for the second place. The first one we are sketching for the first place. The first place is one. For the number two is the second place is one.
Yeah, second place is 1 here. Yes.
So if it was like nine, sir, can you say nine?
Here 9.
Yeah.
Number like
Nine
this.
A. Number 9A.
9. 9. So 9 is how do binary equivalent of 9? Hmm? Binary equivalent of 9 you can find like that. You can just divide by 2. This 4. Balance is 1. Again divide by 2. 2. Balance is 0. We divide again by 2. 1. Balance is 0. 1 0 0 1. Hmm? This equals 1 0 0 1. Okay? A is 10. What is 10 binary equivalent? 10 divided by 2. So 5. Balance is 1. Divided by 2. Balance is 1. Here balance is 0, no? Balance is 0. Then 2 divided by 1. Balance is 0. 1 0 1 0. So this equals 1 0 1 0. So this equals 1 0 0 1 1 0 1 0.
1.
Okay. So this is the decimal equivalent. This is hexadecimal equivalent.
Yes.
So very simple, right?
Yes. Right.
Converting binary to hexadecimal and hexadecimal to binary.
Sir, can you tell me till where we will stop? Like A, B, C, D, E, F, till G we will stop, sir. Up to G there is H, no H.
Only up to 8, no?
Which alphabetic?
Yeah. Plus 6 letters of the English alphabet you use for hexadecimal for last 6 digits. Hmm?
That's it.
Okay.